Hello, in this video we will be talking about Markov chains, which is a high-level topic under this subtopic of statistics and probability, more specifically in the subtopic of transition matrices and Markov chains. Welcome to the world of Markov chains. Have you ever wondered how you can predict the future? For example, what's going to be the weather tomorrow? Well, with Markov chains, you can use this, including other things to predict the future. Let's dive right into it using a practical example using the weather. Now, a Markov chain is a mathematical model that describes a system that transitions between states based on fixed probabilities. Now, important to note that the Markov property states that the next state depends only on the current state, not the history of prior states. It often represented using a transition matrix or diagram that I will show you in a few seconds. This makes useful for predictions and simulations. Now let's talk about our example. Here we have three probabilities depending on the weather. The yellow circle represents if today it's sunny, that tomorrow will also be a sunny day. The blue circle represents that if today it's a sunny day, tomorrow will be a cloudy day. And the green circle represents that if today it's a sunny day, tomorrow will be a rainy day. This can be better represented in a diagram, such as the one that we have here. The circles with the labels represent each state, in this case, weather conditions, sunny, rainy, and cloudy. Each arrow represents the probability of each state changing to another state or staying the same. For example, if today it's sunny, it has an 80% probability of being sunny the next day. This is represented by a 0.8. And each arrow has its own probability. For example, if today it's rainy, it has a 0.3 probability of tomorrow being cloudy. With these diagrams, we can represent in a more visual way our Markov chain. And now, we need to transform these values into a transition matrix for us to calculate the Markov chain and its results. Now, we have to make a transition matrix. In this case, the transition matrix for the diagram I just showed you will look a little bit like this. It has our labels for a more clear visual. So the S represents sunny, the C represents cloudy, and the R represents rainy. These values are the same ones that are in the diagram. So if it's sunny, the probability of it staying sunny is 0.8. Of it shifting to cloudy, it's 0.1, and so on. So when we have our diagram, we need to make a transition matrix just like this, where we will put our arrows and columns depending on our states. In this case, as we only have 3 states, this matrix will be a 3 by 3 matrix. And all of the values are on the diagram and are represented correctly. Now, for the important part, I will show you how to do the calculations on your TinSpire calculator. So now that you've opened your TinSpire calculator, I will show you how to add your transition matrices and do the calculations you need for getting the results. So first, you're gonna click a new document by pressing 1. And now add calculator by pressing also 1. Now that you have your brand new calculator, you're gonna press menu. By clicking menu, this will appear. Now you will click 7 for matrix and vectors, 1 for create, and then 1 for creating a matrix. In this case, we will be creating a 3 by 3 matrix by clicking a 3 number of rows and 3 for number of columns. Now that you have your transition matrix, we will put the values that we just made on the last transition matrix. But now we don't have the labels, so we just need to be careful. So it's 0.8 for it remaining sunny if it's sunny, a 0.1 if it's sunny and for tomorrow being cloudy, and a 0.1 for it turning rainy. And we will add all values to this transition matrix on our calculator. Now that we have added all our values, we'll now click enter to registering the transition matrix. And now for easy access, we will store it. We will click control and then we will click on the button that says variable and it has a store icon above. So control, store, and now I'm going to save this transition matrix as A. Now our calculator knows that A is equal to this matrix. So now if I just play A and click enter, it will now show me the matrix I just placed. And now, what happens if I want to know the probability of a weather occurring, for example, let's say in 4 days? For this, what we have to do is multiply our matrix to the power of the days we want to calculate. In this case, it's 4 days. So we'll click on matrix A and elevate it to the power of 4. What this is making, it's multiplying the matrix itself by 4 times. And now we will click enter to get our results. So now, what this result means is the probability of each weather occurring after 4 days. Looking this matrix at first glance can be a little bit confusing, but if you know how to read it, it's really easy. So, the rows and columns stay the same. So for example, the first probability that we have is that if today it's sunny, it has a 80% probability of it remaining sunny. Now, after 4 days, it has a 62.5% probability of being sunny after 4 days if today it's sunny. And now, for example, let's say that we want to figure out what will be the weather in 4 days if today it's a cloudy day. So that means it's the second row that means cloudy. So in this case, the most probable weather is going to be a sunny day as it has a 58% probability. Or let's say that the question you're being asked is stated this way. If today it's a rainy day, what is the probability that after 4 days it would also be a rainy day? So we would look our value at the bottom right corner because it's the rain column, the rain row. So that states that the probability of being rainy in 4 days, if today it's rainy, it's about 22.97%. I know this matrix can be a little bit difficult to look at as there are many values, so now I will show you an extra step you can take to make it easier for you to interpret the results. So first, we're gonna create a new matrix as I showed you before, but now we will create a 3-row and 1-column matrix. And it needs to show like this. So now we will now create our initial vector, meaning, for example, that we want to know the probability in 4 days of anything, and today it's sunny, it will be represented like this. As today it's sunny, it has an 100% probability of being sunny, as we already know what it is, and it has a 0% of being cloudy or rainy, because today it's sunny, it's what we know today. And now we'll do the same, we'll click enter, and we're gonna store our matrix by clicking Control and store. Now I'll save this matrix as B. So we have our initial vector stored as b, we will multiply our transition matrix to the power of 4, in this case, multiplied by our initial vector, which is b. And that gives us this result, which is 0.25, 0.5825, and 0.5422. And now, if you look closely, it's the same values of predicting something if today it's sunny. As you can see, it's the first column. This is an extra step you can take if you find it confusing on reading the transition matrix of your result. I recommend that if you're in exams, skip this step as it will take you some time. Markov chains can not only be used to predict weather, but also to modeling stock market trends and optimizing traffic lights. And there you have it. Now you're an expert on using Markov chains. Thank you for watching this video.